Welcome to Cpp.chat, the youngest podcast for C++ developers by C++ developers. Before we continue, I'd like my fellow host John to read this week's disclaimer.
Thank you, Phil. The copyright proprietor has licensed this episode, including the soundtrack, comprised of this YouTube video and audio podcast for home use only. All other rights are reserved. The definition of home use excludes the use of this episode at locations such as clubs, churches, hospitals, hotels, oil rigs, prisons, and schools. Any unauthorized copying, editing, exhibition, renting, exchanging, hiring, lending, public performance, diffusion, and or broadcast of this episode and any part thereof is strictly prohibited, and any such action establish liability for a civil action and may rise to criminal prosecution. So we have two new guests this week. Brian Heim is a programmer and musician. He's a junior developer at DRW Holdings in Chicago, one of the maintainers of Super Collider for the last year and a half. This is Brian's first time as guest, but he has been on the panel for C++ Now 2018. Brian, welcome back to CPP.chat. How has being a student volunteer at C++ Now changed your life?
Thanks, John. It's good to be back, and thank you for inviting me. Thank you, you and Phil. Being a volunteer at C++ Now is fantastic. I saw so many great talks. I learned a lot. It pushed my motivation and desire to learn more about C++ to an entirely new level.
Did we work you to death?
Yeah, I recovered.
You didn't work him hard enough.
I think the recovery is from lack of sleep, but I don't think the lack of sleep is because we worked him so hard. I think it's because there's just a lot of cool stuff and a lot of nice people to talk to and stuff like that.
Yeah, absolutely.
All right. Timur Doumler is also a guest for the first time. Timur has been an audio dev for many years at companies like Native Instruments, Juice, and Raleigh. For the last couple of years, he's served on the standards committee. And like Phil, Timur works with JetBrains. And like Phil and me, he works on conferences, serving as a program chair for the Audio Developer Conference, ADC. Timur, what should people know about ADC?
Hey, John. Yeah, thanks. It's really great to be here. Thanks so much for inviting me. ADC, yeah, it's the Audio Developer Conference. So it takes place every year in London, in the UK. We have been doing it for
third.
This is the fourth one. We have been doing it for 4 years now. It's the conference for audio software development. So it's 2 days. It's 4 tracks of talks. It's going to be 20th and 21st of November. Registration is now open. We also have a workshop day on the 19th of November. Yeah, so it's a conference. So it evolved from another event called Juice Summit, which is a conference mostly for, it used to be a conference for people doing like audio plugins, music production software, C++. Now it kind of expanded. So now, it covers audio on desktop, mobile embedded, 3D audio, other programming languages. This year, we're going to have talks about web audio, about audio for games. I'm really excited about getting that industry on board. Yeah, so it's just all
and you
kinds
do this
of audio
all
stuff.
You squeeze all this in 2 days?
Yeah. Yeah, we have 4 tracks. We have about 40 talks in total, I think. And we try to kind of balance it out so that there's a little bit for everyone who cares about, programming and audio and music and sound.
So this was the thing that shouldn't have been a surprise to me, but kind of was, that you told me that almost every audio dev is secretly a musician as well, and that this conference is kind of amazing because there's people who are sometimes performing music or sharing music all through the conference, right?
Right. So this year we're trying to get some kind of live performance, a bit more than we had in earlier years. We also have, on the last evening, we always have the open mic night where you can just go on stage and play the piano or something, and come up with some performance thing.
Are you going to create an ADC band?
That's a good idea. Maybe, yeah, we should be doing that. Yeah. So you have a band, don't you, at CPPCon?
Well, we do. Herb picked them. I don't know where he came up with them, but I love them. I think it's great.
Yeah, they're really good.
It's a lot of fun. And so we're going to have to go through that process again, because after we move the conference, we're going to want to, because they're a local band, local to Seattle.
And
so we'll need to find another one.
And also make sure that there's also a piano, like
oh, I'm sure if Herb has anything to do with the conference, there will be a piano like. But So this is what we all have in common, which is we're all musicians except me. We're all very interested in music except me. We've all done music software except me. So I guess we're not really all in common.
It's never too late.
Oh no, for me, it's you know, I wouldn't subject that to anyone. But I am very interested in, of course, C++ in general. And so what does audio code look like? I guess what I'm saying is, how do you use language different than I would if I were writing something to do like I'm writing C++ to do a desktop application, or I'm doing something like that. Are there language features you're likely to use that I wouldn't use, or vice versa?
Well, I guess a big part of audio applications is the same as any other app. Like there is a graphics interface, there is, you open and save files, or you do something else, which is going to be the same as anywhere else. But then there's also the actual audio processing, which is kind of a real-time thread where you get like a callback from the operating system, and it gives you a buffer with the actual kind of memory mapped buffer that the sound card is going to output to the speakers, and you're going to hear something. And you have to process the audio, actually create audio or whatever you're doing, and write that into this buffer with kind of real-time constraints. So there is an aspect there that maybe we share with people like, finance, trading, or gaming people, where you have to do computations very quickly under kind of near real-time constraints. And the thing is that if you fail to do that, then, if you're like a millisecond too late, then your speakers are going to output some garbage, then everyone's going to hear that. So you can't really do that. So we have this kind of aspect of having user interfaces and all the stuff that everyone else has, and then also this kind of real-time component for which C++ is like a really good language. So
one of the things that I've noticed, and again, I'm not a music person, but I do, work on a lot of videos that go out that we put on the web. And one of the things that I've noticed about videos is that if your video quality is poor, people will put up with that. I mean, they won't get excited about it, but if there's fades in light or something like that, or maybe it's hard to read the screen or something like that, people will put up with that. But if your audio quality is poor, if there's hisses and pops, and if there's a noise, no, we're just not. It's not worth putting up with. The quality of audio, what I should say, when audio fails to be high quality, users definitely notice that.
Yeah, and on the programming level, basically the way it works is, you get a callback every millisecond maybe, and then you have to write, I don't know, 256 floats, which have to add up to some nice sounding audio. And if you throw an exception in the middle of that, or for whatever other reason, you fail to write into that buffer within this 1 millisecond, the user is going to hear a crack so it's going to be audible. So basically, you can't do that.
Even a failure of one callback.
Yes.
If you were to drop one callback,
yes, it's audible. Yes. So especially if you do something like live performance, that's just unacceptable, right? So we have to get it right every single time when we write some when your program writes out some data. And no, that's interesting. That's an interesting challenge. There's a lot of stuff that you cannot do, that you cannot use. Like you have to use code where it's kind of real-time safe, right? It's not going to allocate, it's not going to block, it's not going to call something somewhere where you don't know if it's going to hold a mutex, it's not going to throw an exception. You have to write code in such a way that you know how long it's going to take, or it's going to always take a limited amount of time to execute. It's an interesting challenge.
Yeah. So Brian, you've been working on Super Collider. Can you tell us what the heck Super Collider is, and then tell us a little bit about what that code looks like? And is that any different when Timur is saying, or is it pretty much exactly what he's laying out?
Right, yeah. So Super Collider is an open source project meant for electronic music composition and analysis and performance. It consists of three major parts.
Okay, oh, sorry. Break that down for us. Yeah. You just said, what, composition analysis?
Yeah.
Music. What does that mean? I don't know what music analysis means. I'm just I'm sorry.
No, of course, yeah. We have some people in the computer music community that want to do, for instance, music information retrieval, where you analyze an audio buffer in order to determine different characteristics of it. You might want to classify the genre, which is a fairly complicated task, or you may want to just figure out, is this, the beat the tempo of the music. So that's the kind of things I mean by analysis.
So
yeah.
How do you get the tempo of a music? Is this something you do analytically, or do I actually look at something on the screen which shows me some kind of waveform shape or something, and I look at that and say, look, there's a beat, there's a beat, or how does that work?
Yeah, well, if you want to do it programmatically or in real time, there's a large body of very complicated work that I can direct you towards. It's a difficult problem, actually. You'd be surprised how hard it is to get your computer to tap its foot in time.
And I suppose, I mean, I can at least imagine what that is. But that's got to be easy compared to, say, could I programmatically figure out the key that something was in? Or, I mean, those seem like that'd be much harder. Wouldn't that be much harder than to figure out the beat?
I think that's actually easy. I'm not too involved in this field, but I know that they're working on this kind of stuff.
Okay, so get back to Super Collider. I didn't mean to distract you. And,
no,
on that.
Yeah, no worries. Questions are welcome. So yeah, I would say it consists of 3 major parts. There's a programming language, a fully fledged programming language, which is sort of in the style of Smalltalk, a little bit of Ruby, a little bit of an older language that I haven't heard much about called J. And then there is a separate...
Wait a minute. So what do you do in that language? I mean, do you piece together buffers? Or I mean, what is it that language is used for?
Yeah, so the language is primarily used for communicating with the second part of Super Collider, which is the audio synthesis engine, which is the thing that takes all of the commands about what kind of, do you want a sine tone or a square wave? Do you want a filter? All of the audio effects, it takes all of those and combines them into a single low latency processing graph and runs all of that and generates the audio. So the Super Collider language itself is generally not used for making any sound specifically. It's used for communicating with the server, sending it commands. And then Super Collider language is more of where you would be manipulating your data and doing things out of time, like sorting lists and things.
Okay. And how did you get involved in it? You didn't start this project. You joined it.
That's true. Oh, and I wanted to add that there is a third component, which is the IDE for editing Super Collider code, which has special utilities built in for dealing with the specific things that Super Collider does, like communicating with the server. Okay. Right, yeah, so how I got involved with Super Collider, so my background is primarily in music composition. I studied that in undergrad and at graduate school, but I had studied programming before that as well, and kind of dropped it for a while to focus on music. And then I started taking classes on electronic music and Super Collider, and I just fell in love with it. I started doing that for most of my music. And after grad school, I decided to take a break from music for a while and start focusing more on my interest in computer science. And Super Collider, the project itself, seemed like a really natural way to get involved with that. I knew C++ is used for a lot of audio programming. That was an area I was interested in. So I took a few classes on C++. I started contributing, and people in the community were really welcoming and really helpful. So I just stuck with it ever since then.
Okay. So what is, I'm not sure exactly how I'm trying to ask this question, but in the world of computer music, is it well established certain standards? In other words, is there a format for music that different pieces of software are going to recognize that they'll input and output, or are we just kind of in a situation where every piece of software has its own proprietary idea of what it thinks music is?
I would say, you want to jump in, Timur?
No, go ahead.
Okay. I mean, I would like to augment this answer because I'm relatively new to this, I would say, compared to you. But yeah, I mean, the one standard I could definitely think of is MIDI, which is a quite old standard at this point. Just samples, like the audio formats that we're all used to, MP3, WAV, FLAC, those are, maybe you can consider them standards. But yeah, there tend to be more specific and proprietary things like VST. Super Collider has its own plugin toolkit that you need to write in order to have a plugin for the Super Collider server. And it also has a special format, a binary format for specifying audio synthesis graphs as well.
Yeah, can I just add a few
Go
things?
ahead. Yeah.
So I think it's actually interesting because to answer your question, I think there is no real standard. It's very fragmented, I think. So, if you're doing like music production software, there's all these plugin formats like VST, audio units, and if you're doing kind of like game audio, then there's other frameworks and there's different frameworks. It's different. Like every operating system has their own API. Apple has like Core Audio, Windows has like Wasabi, and there's like on Linux there's several others. On mobile, like Android has its own thing. So. And there's different frameworks, again, that kind of glue them together. So it's a bit fragmented. I think it depends on what sub-industry of audio you're in. And then probably there's going to be some things that people tend to use. But overall, I think like maybe on the very, very low level, like how audio is represented, in the computer, there's like more or less like one or two standards. Like most of the time you're talking about, you have like a audio wave, and then you're going to sample that, and then every sample is going to be like a float basically, and then you're going to have channels. So that's more or less the same stuff conceptually, but then the kind of higher levels, like how you handle that stuff, that's going to be different depending on what you're actually doing. So it's a bit bad. I think it's very fragmented,
but it's driven by requirements. It's not a question of kind of not invented here where everybody feels like they have to invent their own. It's because what we're trying to do, we have a different set of requirements than what other people are trying to do. So of course we have to have our own way of storing it. Is that the way it is?
Yeah, I guess that's an accurate description.
Yeah, I would say it's probably somewhere in between. I mean, artists are very tied to the tools that they use. And I mean, having been a composer myself, the tools that I use strongly influence the kind of art that I create. So I think it's not so much not invented here. It's just that people want to have a sense of that their tools that they're using are on their side and are helping them.
Yeah. So I think there's many kind of sub ecosystems. Like for example, when I was working at Native Instruments, I was working on an application called Contact, which a lot of people use. It's like a sampler. A lot of people use it to do things like, soundtracks for Hollywood films or something like that. And then you have like this whole world in there where you can write like a sample library where you sample musical instruments. And there's, I think, many of these worlds in a way. And then depending on what you're doing, you're going to end up in a different ecosystem and rely on that. And there's just a lot of them. I don't know. Does that make sense?
I think that's accurate, yeah.
I think so. I think so. One of the things that you mentioned, Timur, is that you've been working in the standards committee. Is that directly related to your audio work, or is that maybe more your JetBrains work?
It's actually really weird. So the way I originally joined the committee was because I was working in audio, and then someone noticed that there's no people from the audio industry on the committee at all, and they were like, maybe we should have someone who knows about audio stuff, who can represent, this industry on the committee. And then, is there anyone around who wants to do that? And then I was kind of the only guy who kind of raised his arm and said, hey, this sounds like fun. And then I started going to committee meetings, and I started enjoying this whole kind of language design thing so much that I actually then switched jobs and took on a job that has nothing to do with audio, but has all to do with C++ language, because I felt that this is something I really want to learn more about. So now I'm representing JetBrains on the committee, but that's not how I originally got in. So it's a bit weird.
Right. So are you working on ReSharper and Sea Lion? Are you part of that team, or
yes.
you just represent JetBrains, or what's your role?
So my day job is I'm a developer in the Sea Lion team, and I'm doing kind of the C++ front end language stuff. So kind of parsing, resolving. So the last months I have spent implementing several like C++ 17 features, like class assembly argument deduction, or like some other stuff like the if with initializer and the fold expressions and things like that.
So I saw your talk where you were pointing out some very bizarre things and say, how does the language resolve this? Because I guess that's what you do in your day job, right? And you're saying, what are we supposed to do if code looks like this?
Yeah, it's actually really funny, because if I remember myself as a C++ developer when I was just writing code, and then I was staring at code like this, and it didn't compile. I didn't understand why. And then I was like, well, maybe we should just not write code like that. And then you write something nicer that compiles. Right now, it's completely different, right? I have to imagine every single piece of code that someone could possibly write. And then if it's valid, we have to deal with it correctly. If it's not valid, we have to not go into an infinite loop, kind of recover in a reasonable way, show a reasonable error message, and you're on this kind of meta level. And I think that's really fascinating. I really like doing this kind of stuff.
Well, I get that sometimes as a teacher, because some people will ask me, say, well, what would it mean if we did this? And, your first response is, well, don't do that. There's all sorts of reasons why that's a bad idea. But that's not the question. The question is, what would you get if you did that? And sometimes it's hard to know, because, as you say, this is like it's a dark corner. You don't really want to go there. Well, but what if you go? I mean, somebody has to resolve that. Somebody has to figure out, what does this actually mean? And
what I do is I keep a list of these things. Like regularly at work, I encounter snippets of C++ code which are so weird that you just don't know what they're doing. But either it's a bug that someone filed, or there's this new feature and you can maybe write this code with it, but we don't really know. So I keep a list of these weird snippets. And sometimes when I'm at a conference, I just show them to people. Like when I was at ACCU, I was talking to Richard Smith, and a few other really hardcore C++ people, and I was showing them a snippet of code. What does this do? And it was not much code, and no one could figure it out for at least 10 minutes.
But I bet it was Richard who finally figured it
out. But that's just maybe for fun. That's most of the time you're gonna be like, okay, no one's gonna write that. You're gonna probably fix the more important bugs. But this stuff comes up really, really often. I think I'm gonna have some of that stuff in my CPPCon talk. I submitted a talk to CPPCon about parsing C++, which got accepted. So gonna draw from that list, I think, a lot in that talk.
I really like your story about structured bindings, when you were implementing support for structured bindings and you noticed a flaw in the standard.
Yeah. That was the first one that I did. That was the first C-line feature ever that I implemented, was support for structured bindings. And then I was writing it. I was just reading the standard. And then I wrote some tests, like, okay, you can probably do this, probably do that. And then it was about if you're in a class and should you be able to bind to your own members. And then the standard said something about, well, they have to be declared as public. And then I was like, but if you would use the normal access rules that every other part of the language uses, right? Then I could just reuse that code in C-line, and I wouldn't have to write this other really ugly code. And then I was like, maybe that's a defect. So I wrote a paper, and then, hey, let's change the access rules for structured bindings. And I went to a committee meeting, and everyone said yes. So it saved me a lot of time, because it took like an hour to write the paper. It would have taken at least a day or two to get C-line's code to do what the standard said at the time. So we got it in as a defect report. That was pretty cool.
And that calls back to something that we were talking about earlier when we were talking about syncing the Vasa and all these papers. And I was just saying, some of those papers don't really make the language more complicated. Some of those papers actually make the language less complicated. Because sometimes you just go and say, if you look at it from the perspective of someone who has not been in the room when the feature was designed, like 4 or 5 years ago. Yeah.
It's like, well, obviously this is easier, right? And then you go there, and then, in this case, Herb Sutter, who was the main designer of this feature, said, well, now that you say it, I think that was the intention of the design, And then it's just an easy fix in the end sometimes. It's like, yeah, obviously. Sometimes it's not as easy. Sometimes no one can figure out how to do it correctly, or there is no correct way.
Okay. So you're still very involved, though, with the audio side, because you are program chair for ADC, and has the ADC's in November this year.
Yes.
Has the call for submissions gone out? Have you?
What
what your program is now?
Yeah. So that was my last 2 weeks, basically. My day job here in JetBrains, and all the other time was eaten up by ADC stuff. It was basically the submission deadline was over, and then we had all these submissions. So there was a program committee, and so that I'm kind of running, and people are writing reviews. I mean, John, you know this. You know exactly what I'm talking about here. So, then you have all these, I
was going to say, we have to get the schedule, not just the list of accepted talks. We actually have the schedule up by Wednesday. That's our deadline.
Right.
And I'm not terribly close to that. So there's going to be some,
Yeah,
there's going to be a few nights between now and then to make that happen. But
don't let us keep you up.
Yeah. So
Yeah.
Brian, have you looked at that schedule? Are you ready to go off to London?
Oh yeah, I'm not totally sure I'm going to be able to make it. It looks fantastic.
Yeah.
But yeah, with this new job, I'm not totally sure about that. Sorry.
Sometimes it's hard as a junior dev when you're just out of college and you haven't.
Yeah. Oh wow. But yeah, the schedule does look. It sounds like a great time.
So I didn't talk to you about this, Timur. It is located in London, right?
Yes, so we're in central London. It's called CodeNode. It's actually the same place where Phil runs the C++ London user group.
Yeah.
It's a really awesome location. Yeah, it's 20th and 21st of November, and the day before on the 19th we have a workshop day. Yeah, it's a lot of fun.
How much of it is C++? Because you said you've kind of expanded it to have other languages and stuff like that.
Yeah, I think it used to be almost exclusively C++ like 3-4 years ago, but now it's definitely not the case anymore. So we have several talks about web audio. We have one. Actually, the program is not up yet, but I can already give you like a little sneak preview. I think we're going to publish the first draft maybe in 1 or 2 weeks of the.
Oh.
So we have not published the program yet, but
I see. Okay.
We have already. We know what talks we accepted. We just haven't published the program yet. So one of the talks I'm really looking forward to is going to be audio development in Rust. So that's really cool. It's like another completely different language, which is also, I guess, kind of good for this kind of low latency.
But it's a systems programming language, so
I have never used it, but then yeah, it's going to be by Ian Hobson from Ableton. So it's another kind of relatively known audio music production company, and he's going to tell us how to do audio programming in Rust. So I think that's going to be really exciting. Okay. And we're going to have other non-C++ talks as well.
Okay. And you mentioned that it occurred to me to think about, at CppCon, we've announced one of our plenaries is going to be Mark Elnt, who's worked on Houdini, which is used in the film industry. I assume that you guys do an awful lot of stuff. I mean, by you guys, I mean the audio developers in general do an awful lot of stuff having to do with video, right? And video is, we think of video as the visual stuff, but it has to be in sync with audio. Or almost everything we do in video, we expect to hear sound with it, right?
I guess so. Although I have to say that's not really my domain anymore. We talk about video, but I don't know. Maybe does Super Collider have stuff like this? Because I know I've used things like Max or Pure Data, and then there are ways to interact with video. So how is it in Super Collider?
Yeah, I would say in Super Collider, it's not much of a priority right now for adding video capabilities.
Right.
Yeah. That is the syncing aspect. It just brings in a lot of complicated issues. I do have a friend that works on video stuff, and I hear it's quite gnarly.
Well, they're faced with much the same way, right? I mean, they have a small window to move a lot of data.
Yeah.
Yeah. Speaking as the editor of this podcast and YouTube stream. I started out editing it in Final Cut Pro, which is a video editor, because we were doing video first. And I've recently switched to just doing it in Logic Pro, which is a pure audio editor. Although Logic Pro can actually do a bit of video, and Final Cut can do a bit of audio, but it's a very different perspective from each. What I really want is something that can do the best of both worlds, but I haven't seen anything like that yet. So if you hear anything, let me know.
Okay. Speaking of our podcast, I was going to make an announcement about this, and forgot to mention it earlier, but here's our logo as a sticker. And I'm certain that all of you at home that are watching on video are saying, gosh, I wish I had a sticker like that. And those of you who are listening are imagining the best possible looking sticker you could possibly imagine. And you're saying, I sure wish I had one of those. And it turns out it's stickers, so it's cheap as heck. And we're happy to give them away free, but it's a pain in the butt to mail them out to you. But we're willing to mail them out to you if you will write up a review of this podcast, right? And you can say even mean things about it. I wouldn't be surprised if some of you do, but that's okay. But there are some requirements. First of all, you're going to have to write to me and say, okay, John, here's my mailing address where you can send me the sticker and give me a pointer to your review. And because we're trying to build recognition for kind of the whole community, you must mention CPP.cast in your review, because anybody who's thinking about listening to this show should also think about listening to that show. So you have to mention that. And one other requirement, you have to say, and this is my competitive nature coming in, you have to say that we have more disclaimers or more rants or more fun. Now, you don't have to say that's good or bad. You can say, I hate that show because it has more disclaimers. You can say whatever you want, but they have to mention one of those three things. So we have more disclaimers, more rants, and more fun. If you do that and you send me an email, then I will put one of these lovely little stickers in the mail to you, and you get to have your own sticker for CPP.cast. If you're really nice, I might even put in 2, but I don't want to try to influence your review in any way.
They're not actually as cheap as you might think, by the way.
These are high quality vinyl.
They are
premium. They have to stand up. So yeah, these are the high quality ones. Yeah. But that doesn't mean that if you see us at a conference, in fact, if you're going to any conference, look for either Phil or I. We'll probably be there. And if we are there, we'll be handing out stickers, and we'll also probably be handing out, armbands.
If you're really lucky, we may hand out some T-shirts as well. Possibly even before the T-shirt meal on Sunday.
That's right. That's right. If you're going to CPPCon and you have your review, then definitely mention that, and then we'll make sure that you get a T-shirt for that.
T-shirts are definitely more expensive. We won't be able to give them to everyone.
Yes, probably will. Okay, we'll figure it out. We'll figure something out. We'll make it worth your while. But it doesn't have to be a really favorable review, and we're not saying that. If you wanted to, you could, but you don't have to. Anyway, so we got distracted by the whole talking about the audio show, but the production for the podcast. But what about it, Phil? Do you, in working with audio software to do the show, are you pleased with what's available, or do you feel like, as a user, there's a long way to go?
Well, I started working with audio software, not on the development side, but just as a user in the early 90s. I've definitely seen it come along a long way in that time. I mean, as you would expect, but it's just mind-bending. If you took what we have now, sent it back to me in the 90s, would be blown away. But now here I am, and I'm complaining about it because sometimes the user experience does suck a bit, particularly in the apps that I mentioned, Logic and Final Cut. That they are amazing apps. But they can be quite frustrating. A lot of pro software can be like that. But I'm still waiting for something that will do the best of both worlds, I think. So maybe it's out there. I haven't tried it yet. Let me know. So
if I were decided, I want to be an audio dev, maybe I have some project that I've always wanted to do, kind of my own little music box app or something like that, where I want to be able to, I don't know what I might want to do, but what would you recommend? I mean, how do I figure out what I need to do? What are the skills I need, and what do I need to read, or where do I need to go? What websites are helpful? What community should I plug into to learn the ins and outs? Other than obviously I should go to ADC. That goes without saying.
That's a really tough question. Actually, another talk that people have at the ADC is how to do that, what you just described, because it seems to be really hard to figure out if you're starting out as an audio developer, to even figure out where to go or where to get resources. And it was hard for me when I started this. I think, again, it depends a little bit on what you want to do. You want to, if you want to do a mobile app, for example, that where you can kind of play a little keyboard, or I don't know, what kind of thing would you want to do?
Well, okay, let's say that. Let's say I want to be able to do something where I play a tune, it plays it back, or maybe I play several different tunes and it memorizes them all, but then randomly plays it back to see if I could remember it and do exactly the same thing. Some kind of repeat me kind of thing. You see what I'm trying to say?
Yeah.
So it randomly picks one, it plays it, and then I have to see if I can reproduce those notes.
Right. So yeah, there are several solutions for that. Like one, obviously, that I was involved in is Juice. It's a framework that's kind of cross-platform, and it tries to be like easy. So the aim is kind of that the code looks like it doesn't have like lots of highly templated, complicated stuff. Like it's kind of easy code that you can write. And normally you would have to go to kind of iOS Core Audio, which is like the API on Apple, or you would have to go to Windows, and then there's another API, and Juice kind of says, okay, well, don't worry about that. There is this much easier API, which is kind of documented, and then there's a forum, and then you can jump in there and try to kind of play around with it and piece something together. There's tutorials on the website. Like how do I do a simple app that outputs random noise or that outputs like a note or whatever. And then you can just kind of do these tutorials and put together the little building blocks and then get something going. And I imagine that kind of other frameworks, other libraries have similar things, but you kind of have to pick the tools you want to use. I guess there's no like one solution for everything.
And I didn't think about this when I was asking it. I was thinking about it playing audio, but I guess the really challenging part of the app I just talked about would be analyzing if what I played matched. Because, I mean, it's not going to be a perfect sound wave, right? I mean, it wouldn't be a perfect match. There's going to be a lot of, maybe I held down the note several microseconds longer and I, as a human, couldn't even detect it, but it would cause the computer to see a mismatch, right? How hard is it to do that sort of thing, to have the user play something and then you match and say, is that close enough? Is that hard to do?
I think so. Yeah, there's a lot of algorithms involved. There's probably libraries that kind of you can find that do some of the work for you, but that doesn't sound like you can do that in a day or so. And what I find frustrating a little bit is that there's not many books and there's not many people, going to conferences and doing talks about this stuff. And
are all the ADC videos, I mean, I should say all the ADC sessions, are they recorded and put on YouTube?
Oh, sure. Yeah.
So is that a good place to get started?
That's a great place to get started. Absolutely.
Are those targeted at beginners, or are those kind of, no, we assume you're already a professional, or is it a mix?
I guess it's kind of balanced. So of course we have talks which are like really hardcore, here's a great DSP compression algorithm, which you have never heard about compression algorithms before. You're probably not going to get much. But then there's these other talks which are more kind of entry level. So yeah, I guess it kind of covers the whole range. We have people coming to the conference who have been audio devs for like 30 years. We also have lots of students coming who are very new to this, and so we try to get something for everyone.
So yeah, I'm comfortable with that.
Yeah.
I think there's a certain number of talks there that are not strictly audio specific as well, that may be to do with techniques that you have to use in the audio world, like lots of low latency data structures and algorithms. But
yes, like your talk, for example.
Yes, like my talk, for example.
Do you want to talk about that?
Are you speaking at ADC?
I am speaking at ADC. It'll be my first time speaking there. I've actually been to the last two because I've been on the booth with JetBrains. In fact, I first met Timur a couple of years ago before he joined JetBrains, because I was on the booth at ADC, and he was one of the organizers of the conference then. So this year I'm actually going to do a talk, and it's a variation on the talk that I've been doing at some of the other conferences on error handling and exceptions. And of course, exceptions as we currently have them are really not suitable for the sort of low latency environment that you have in audio, because of non-determinism, because of the performance overhead and heap allocations. And they're the same problems that we have in other domains. So the thing that my talk builds up to is Herb's static exceptions proposal that we've talked about on this show before. And I've done a variation of this talk at a couple of conferences already. This is going to be slightly different because it is focused more on the audio industry specifically. But it's really the same core material. So if you've seen it at other conferences, you'll be familiar.
Yeah, I'm really excited about that actually, because exceptions is basically a no-go for most of audio applications. You just can't do that. But if there's other ways, so a lot of people do error return codes or things like that. Those techniques are very much alive, kind of in audio code. So hearing about new ways of doing things is, I think, really.
Well, as soon as you say real time, which is the way you described audio, as soon as you say real time, you're immediately saying, no, I don't think we're even doing any exceptions.
Right. Yeah, that's exactly what's going on. So when
I've done this talk at more general C++ conferences, of course, there's a few people in the room that work in low latency environments, and they'll give their feedback, which is really valuable. But there are people that are already going to the general C++ conferences. What I'm expecting at ADC, hopefully, is I'll get people that I wouldn't normally meet who are right in the heart of that environment to see what their reaction to this is. Is it something they're going to trust? Are there going to be other issues to overcome? So that's going to be really interesting for me.
Yeah, sounds like you're going to get that.
So Brian, you may have missed your chance here to step in and say, if you want to learn to do audio development in C++, you could volunteer to work on Super Collider.
Yeah, that's very true. Yeah.
But this is open source, right?
It is. Yeah, it's GPL3.
So if somebody was trying to get their feet wet, you don't expect that everybody who tries to help out has to already be a pro, right?
No,
you could guide them and say, this is where you could get started and learn about what we're trying to do.
Yeah, absolutely. I mean, because that's basically where I came from. I had basically about 3 months of experience working with C++ when I started working on Super Collider. Yeah, it's very newcomer friendly, or at least we try to be, because a lot of the people coming to it are people that are like me, primarily musicians, and are fairly new to development. So yeah, it's a good community for that, I think.
So how big is the community? How many people are actively developing in that on that code base?
Well, last month we had 17 different people contributing. That I feel like
that's pretty good for a source. Yeah, that's pretty good for a source open source project.
Yeah, I'm quite happy with the direction that the community's taken in the time that I've been on it. I would say overall we have about 40 people that are doing development work in some way, and those people come in once in a while. Sometimes they'll disappear for a couple months and then resurface.
That's life.
That's life. Yeah.
And so as a newbie, they were nurturing and supportive to you. They didn't give you a hard time about whatever mistakes you might have made. At 3 months in C++, I think most of your mistakes are still ahead of you.
That's probably true. I would agree with that. Yeah, I mean, most of the initial contributions I made were actually on the documentation side and on the
because you were still getting your feet wet on the app and figuring out how it worked and stuff like that.
Yeah, and changes also in the language itself, not in C++, but in Super Collider code. And then I started becoming a little bit more confident in C++ as time went on and doing things there. So that's actually, based on my path in, that's something that I've been very conscious of, is trying to make it easier for people to contribute in general, just documentation in other ways that aren't specifically like going in and using Git, because a lot of musicians are not so comfortable using Git. I think just as a lot of developers aren't comfortable with playing the guitar.
Well, I think there's a lot of programmers aren't comfortable using Git. So
that's also fair.
So I don't think I'm not surprised that musicians aren't either.
Yeah, although interesting side note, I do have a friend that has given a talk, I think multiple times, about using Git to compose music as like a way of saving, using it as a revision tool for your music.
I haven't really thought about it from the music point of view, but it does seem to me like if you're a writer, this would be a great tool for you to use, because I know that's what happens. I know that also visual artists are affected by when they can start using digital medium and then hit the undo button, because that's, it's, this was many years ago before I was married. I was dating a woman who was a student in a graphics art discipline, and we'd be on the phone while she's working, and every once in a while she would swear. It's like, what's the matter? And she says, oh, I smudged it. And I would so helpfully say, well, can't you just do an undo? It's like, no, it doesn't work that way. But let me ask you this. has understanding about how music's played at a low level by a machine, has that affected your composition anyway? You said you do composing, right? Didn't you say that?
That's true. Yeah, that's very true. I think it's well. I mean, I think the ramifications of that are coming down the pipe because I kind of slid into development right as I was easing out of composition. But I did some work at the same time, and definitely the work that I was starting to do was much more low level. I mean, when I was doing acoustic composition, I was always interested in theory and very detailed aspects of music theory and algorithmic systems that I would use to compose my music. And now when I'm doing digital music, I'm very conscious of what's happening exactly in all the audio processing algorithms and like how can I manipulate the individual values in audio buffers. I was doing some of that, I think, a couple summers ago. Yeah.
Do you ever just play with it and say, what if I just did some mathematical operation on this just to see what it sounds like?
That's,
you know what I'm trying to say?
90% of what I do.
Oh, I see. You're just playing and hoping that, you know, sometimes it sounds like, oh my gosh. And then sometimes it's like, oh, that's kind of interesting. We could explore that a little more, right?
I think some developers would be familiar with this workflow. You try a whole bunch of ideas until it sounds good, and then you kind of go back and if you want to, if you have time, you go back and try to figure out why exactly what's happening is happening.
I see. And then when someone asks you your process, you never reveal how much of it is trial and error. You just say,
no,
I was inspired.
Yeah. Exactly. Then you say, you know, I just went on a walk in the woods and it came to me.
Yeah. I observed a few times, you know, if you work in a company that makes audio software, you have developers, you know, you have DSP engineers who make the algorithms, which are sometimes the same people and sometimes not the same people. And then there's the sound designers. And these are the people who just, you know, they never see your C++ code, but they have all these buttons and they design, you know, the presets for your synth or like other sounds that they think are cool. And just observing this creative process of these people, it's just magic, you know. I have no idea how they come up with what. But yeah, so what comes out is great, but like how they arrive there, I have no idea what they're doing. They just can. I think so. For me, it's just parameters, numbers, right? I have a synth with like 50 parameters. I don't even know what they mean, right? And those people, I think they have some special part of their brain which can map these numbers into something that makes sense, you know, and kind of play with it. And yeah, I have a lot of respect for that. I
think that's a really interesting observation. Like, I think one of the things that was freeing for me about starting to use Super Collider for sound design and for like for composing was that I can assign different parameters to, for instance, the mouse position on the screen, so X and Y, and then to other faders that I have, and immediately start exploring a parameter space, like 3 or 4 dimensions. And you start to, at least I do, I start to like physically map what's going on there. I know, oh yeah, well, mouse is up here in the corner, and I've got this fader down here. That's like a really nice spot, and I can kind of move out of it easily and get some great transformations.
What is that instrument that's sensitive to position in your hand that's used in all the sci-fi movies?
Oh, the theremin.
The theremin, yeah.
The theremin, yeah. I had a friend who had one, and I got to play with it, and yeah. But it made me think of what you were saying. It's like, you just want some weird input and see how you can, you know, play that input into a sound.
Yeah, I had a plugin once called the Beat Map, which allowed you to load bitmap images in, and then it would reinterpret it as audio, and you could just play it as a sound.
So I would never, ever, ever hint that I'd ever done audio software before, but I almost did that once. Let me tell you the story. Back when I was in college, and you know, those of you who don't believe it, but there actually were computers back in the 70s. My college roommate bought something called a Superboard 64, and that was essentially just a keyboard on a circuit board. I mean, it didn't even have a case, right? It was just a keyboard on a circuit board, and it had like, I don't even think it had 64K of memory, but maybe it did because that was the name of it. But everything about it was just inexpensive so that you could play around with stuff. But the one thing that had that was actually kind of intriguing that a lot of computers at the time didn't have, it had a D to A converter. And so you could actually create a, you know, position the port value to anything you wanted by writing to a port. And so we came up with this crazy idea. What if we could play sounds on this? And it was him. He's very into music, and I wasn't. I would have thought about this. But he said, suppose we could play sounds because we have this D to A converter, and just wire it directly to the speaker and listen to what we get. And so we actually went to the library and checked out a book that had waveforms of different musical instruments. So we picked the violin and took the waveform and overlaid it with a piece of graph paper so we could get the individual amplitudes of or each point along the wave. And the idea was then to figure out mathematically what would be a high C for pitch. I mean a middle C for a pitch, but using this waveform as the repeated wave rather than just a simple sine wave, so that it would sound, instead of just sounding like a sine wave at middle C, it would sound like a violin playing middle C.
So you've been doing wavetable synthesis. That's awesome.
That's exactly, I hadn't thought of the name, but that's exactly what it was. I'm sure it was. Wavetable synthesis. We found the wave, we made it into a numeric table, we loaded it in the program so that it would replay it. And the thing was, did it sound like a violin? And we kind of convinced ourselves that maybe it did sound like a violin, but it was absolutely confirmation bias, because after we were finished, I happened to look at the book again and realized, oh, wait a minute, we grabbed the wrong one. That was supposed to be a flute. and it didn't sound any more like a flute than it sounded like a violin. It was a complete failure. But it was fun.
So there you go, John. You are an audio developer after all. you wrote a wavetable synthesizer.
That's what we did. It absolutely was. It was a complete and total failure. But I actually did learn one thing. We went to our computer science professor. I don't know who it was we were talking about. And I was just asking him about what would it take to capture human speech, because I've seen, I don't know where it was in the movies or something, voice prints, right? What is the sound wave of human speech? And he told me that that Licklider, I can't remember Licklider's first name, is J.C. Licklider or something like this, but a very, very early computer researcher discovered that if you record human speech and then just completely crank the amplitude so that instead of getting any kind of, it's either completely up or completely down, and you turn it into just a waveform and what he called the zero crossings. In other words, when is it that the wave is coming down and crossing the zero line? And he says, if you can capture just the zero crossings, you capture 80% of the meaning of speech, which is pretty good, I thought. But we didn't really have any device to be able to do that. But I just thought it was a very interesting piece of research to throw at you, because it's like,
I can follow up on that story actually, because when I was at school and I was first learning to program with the Commodore 64 in assembly language, I discovered that there was one bit in memory that was always either on or off depending on whether there was a signal coming in through the cassette port. It was there for loading data in off the tape. And what I found was if you turned the sound chip on and off, it made a click. And if you did it every time there was a bit on that port and then didn't do it when there wasn't, you actually got a pretty low resolution but a recognizable sampler. It was enough to do some pretty crude voice sampling. And I used it to do a sample of me saying, "The eagle has landed," for my Lunar Lander game. And it actually took longer to load the sample in off tape than it would have been just to say the word again. But it was fun.
That's cool.
That's really cool.
So tell me, explain this again. The bit goes up when it hears, it's not when the audio is on, but actually when it's hearing sound.
I mean, it's effectively a 1-bit sampler. So it's reducing the signal down to either the presence of a signal or the absence of a signal. And that's it. It's very similar to what you were just saying.
Right. And so then you just captured that and played it back, or you were just doing it live?
We can do it live, but if you just store that in memory. In fact, I actually wasted 1 byte for every bit because it was just easier that way.
Yeah.
And I'm not sure if I could have got the timing right by rotating the bits in.
We need to teach you about vector bool, I think.
This is in 6502 assembler. Is that a 1 kilohertz processor? I think it was. It wasn't very fast, but it was just about fast enough to do that.
So that was before computers were fast enough to do real-time audio.
Yes. Yeah.
About
the good old Commodore 64. I was so frustrated by how slow that loaded off of disk that I started to do some investigation and determined that the reason it was so slow is because they were using the serial port. It was a 300 baud serial port. So they had a disk drive. It could go, the disk drive itself was capable of much higher speeds, but it was reading in through a modem port. And so if you had a high-speed modem, you actually could call up a local bulletin board and download your programs faster than you could load it off of disk, because the disk drive only had a 300 baud modem port on, or 300 baud modem speed on.
You could also write code that would run on the disk drive, and people would use it to do SETI computations. Seem to remember.
SETI?
Yeah. Search for extraterrestrial intelligence.
Yeah. Wow.
Oh, SETI. Oh, yeah. The people who look for aliens.
Yeah.
I know them. They're awesome.
Yeah, there was some on my hard drive, apparently. Floppy drive, sorry, not hard drive. The 1541, I seem to remember.
That's right, the 1541.
Yeah.
That poor guy got abused so much because every possible copy protection scheme involved in some way abusing the disk drive. And sometimes when you put in a piece of software, the disk drive sounded like it was being beat to death, because they would slam the heads, and then scary.
And you somehow brought it back on the topic for audio. How about that?
Well, I'm really glad you guys were able to join us today. I know so little about audio software, despite the fact that I did some of the really, really early work on wavetable. What did you call it? Wavetable
synthesis.
Wavetable synthesis. Yes, I was a pioneer in this area. It would be kind of fun to do it with modern tools and see if I could actually make it work now. But that machine, that Superboard 2, was actually a 6502 based machine.
If you came to ADC and presented that as a lightning talk, I think people would love it.
Yeah.
Well, I'll keep that in mind. I would love to do that. I'm going to see if I can get a hold of the guy that's running the C++ on C conference, and see if I can get him to talk to him about maybe accepting.
Where might he be?
On that. Yeah, well, I don't know. Probably one of those shady conference organizers.
Yeah, you have to be quick. You have to be quick. I think the call for the speakers closes in less than 10 days.
The real challenge is to see if I can possibly attend. That's the problem. Speaking is the fun part. It's figuring out how to get there. That's figuring out if there's room in the calendar somewhere. We can squeeze that in. That's the problem. Anyway, no, it's been great having you guys on. I hope you come back. I hope you give us a report after ADC about how well that went. And I hope to see you guys somewhere at some conference somewhere. I know Timur has been to, you've been to both C++ Now and also to CPPCon, right?
Yeah. I'm going to be at CPPCon again this.
Oh, that's right.
year.
You said your talk is there.
I think my 3rd or 4th time now. So
yeah,
good stuff. Looking forward. Thank you very much for organizing it and also for inviting me here. It's really, really great.
Well, it's great. I love the people who come to CPPCon both as attendees and also speak. Well, actually, I have to always be careful, because sometimes when I say attendees, I make it sound like I don't mean speakers, but all the speakers are attendees. I don't experience many people who just walk in the door, give their talk, and then walk out again, right? They don't go to other sessions. And I know that's a thing, because I've been to conferences like that where I kind of gave my talk, and then I was like, what are the other talks I'm interested in? Not really. But I don't see that at C++. At CPPCon. I think the people who go to speak are excited about attending and excited about going to the other sessions and things like that.
Yeah.
All righty. So anything you want to say before we wish everybody safe coding?
Actually, just one thing to put Timur on the spot.
Yeah.
He's currently in the JetBrains St. Petersburg office, and there's a room on the top floor that's dedicated to audio and music, which he's sitting in right now. It's actually got some acoustic tiles on the wall, and you can see a bass guitar in the background. So I know that room well because I've recorded a couple of screencasts there.
Yeah, and actually the bass has your name on it. It says Phil.
It's not mine.
So yeah.
But I might claim it next time I'm there. And that's our outro music.
Well, how about you, Brian? Anything you want to say before we wish everyone safe coding?
No, just thank you for inviting me on. It's been a blast.
All right. Well, it's great, and I'm glad that you're sharing what you're doing at C++ Now and with the rest of the community. I think that C++ has an obvious advantage for anyone trying to do real-time stuff, and I think we should keep making sure that continues to be relevant. Any other closing things, Phil, that we should cover?
No, I think we've about covered it. We mentioned C++ on C Call for Speakers again.
Yes.
Should also say that ADC, although it's the Audio Developers Conference, I think anyone that's interested in hardcore C++ and other languages, of course, particularly with a real-time slant, might find it interesting anyway. I know I have. So
well, it's like you said, a lot of it is just really, really performant C++.
Yeah,
and you can target that at a lot of different domains.
I think we're over time already, but can I say one more thing,
sure,
which I think is really close to my heart? So, I talked to people who are from different domains, who do maybe gaming or finance or other things that are not audio. But then I see so many of these same problems that people are solving. So, I think we should really kind of, these events are such a good opportunity to kind of keep talking to each other across the different industries, because a lot of the problems that we're solving, especially with this whole low latency stuff, they're the same. So there's a lot to learn from each other, and I see this process happening, it's just, I think, something we should keep doing and maybe get better at.
Well said.
All right. Well, in that case, we will in fact wish everyone safe coding. So for those of you who are watching and we're listening, we say safe coding.
Safe coding.
Safe coding.
Safe coding.